One of the more difficult concepts to get across to students is that of the independence of vectors, that a vector that is 90 degrees to another vector is totally independent of it, so that a vector, a velocity vector for example, that is pointing north has no effect on a velocity vector that is pointing west. So multimedia science has come up with a simulation software that will help you get this difficult concept across to your students. This is accomplished by the use of 5 simulations. The first one deals with a car moving along a wall. Here is the angle that the car is making with a perpendicular to the wall, and we can increase the car's velocity. This illustrates the fact that the vector that in this case is going east has no effect on the car going north. But if we change that, if we change the angle, this is no longer the case. They're no longer perpendicular, and now the car will move north. Each of these simulations has a set of directions. One, by moving the mouse over the parts of the simulation, it will explain what that particular button or that part of the simulation is supposed to do. And there is also a description, objectives, some suggested questions and procedure to help you run through this simulation with your students. The next simulation is the pretty famous motorboat across the river, and you can pick various velocity for both the boat and for the river going east, the boat going north. You can hide or not hide some lines that go along with the boat, and you can also show exactly how the boat is moving both in the north and the east directions. You can also time the boat as it goes across the river. So let's start. You can see that this nicely illustrates how the two motions are added together, and they are independent because each of them is moving independently, and you can stop and start at any point. You can also measure the time it takes for the boat to go across the river. In this case, I haven't picked a particularly good choice because the boat won't make it across the river. Then there's the motorboat problem, where you will get randomly chosen velocities for the boat, the river, and the distance. And then you have to figure out how far down the river in the east direction will the boat end up, and how long will it take the boat to go across the river. This is a very standard problem. Again, you can start and stop at any point. You could ask the students to calculate these distances at any time, or you could ask them to calculate out the answers and put the answers in, and we have to reset here, and you can type in the answer. Let's just say 1.24 seconds, and start. And it will tell you whether or not your answer is correct now. The next one is the fastest time across the river. Students typically think that you can get across the river more quickly if you angle your way up the stream, but you can illustrate that this is not the case by running a number of different cases where you change the angle and measure the time that it takes to cross the river. You can see that's 11.8 seconds. And now let's just let the angle be 0. And you can see that the time now is less, and we just let the boat go straight across the river, all of its velocity going in the, in this case, the north direction. Again, in each of these cases, there's a description, objectives, suggested questions and procedures, so that you have some guidance on how to use the simulation. Finally, there's the fastest time vector diagram. This shows you the vector of the boat. So that's the total velocity of the boat. Here is the velocity of the river. And this little red marker shows exactly what part of the boat's velocity is going, in this case, north across the river. And as soon as we start to change the angle, hopefully you can illustrate this now to your students, that by angling off in either direction, you decrease the part of the velocity that's going in the direction across the river. So hopefully this is a visual illustration that will help your students see why this is the case. So that's the Independence of Vectors demo created by Multimedia Science. I hope you find this simulation useful. So if you're interested in the simulation, you can go to Teachers Pay Teachers at this particular URL and type in the name of the application, the Independence Vector demo, to find out more information.